Good morning, everyone. Um, in this note, we're going to review some stuff about angles, trigonometry, things that will be useful in terms of vectors. Okay, I'm going to be running through this fairly quickly, so just 2 hours running the video. Please pause as the class needs to get the various things down. Okay. So here's the first thing. This is going back to grade 9. Okay, we're talking about the properties in parallel lines. Okay, so the 3 main ones that hopefully you remember from way back when, okay, are the Z pattern, which is called alternate angles. Okay, and that's the blue highlighted part there with the X. Okay, C pattern, which is called co-interior angles. Okay, and those are 2 angles that add up to 180 degrees when they fit inside the C. Okay, and the third one is F pattern. Okay, that's corresponding angles. So that's the red highlight there with the Y's. Okay, and notice I've drawn the F upside down there, right? That's on purpose, right? For all of these patterns, they don't have to perfectly look like it. You can rotate them, you can reorient them. For instance, I'm just going to highlight in yellow for a second here. For the Z pattern, right, it can be this way, and it's this angle up here and this angle down here, right? And it still works the same way. So those are your 3 angle patterns. Okay, so I'm going to move on to the next thing now. So again, please pause as needed to make sure people get things down. Okay, next thing is just to quickly review your basic right angle trig, right? So that's what you may have used the mnemonic SOHCAHTOA, right? The sine of an angle is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And it depends on the location of the angle, right? If I put theta here, then obviously this one is going to be my hypotenuse, this one would be opposite, and this one would be adjacent. Okay, if I put angle theta in the other location, right, hypotenuse would still be the same. Okay, but now this is my adjacent side, and this is my opposite side. So you have to be really careful when you're setting that up. Okay. The other rule that we like to use in right angle triangles is the Pythagorean theorem, okay, which is a squared plus b squared equals c squared. All right. Okay, again, I'm going to move on to the next thing. So this might be a good place to pause for a second if people need to copy. Okay, in non-right angled triangles, okay, we use sine law and cosine law. So 2 little refreshers here, right? For sine law, okay, or sorry, for labeling the triangle, right? If this is angle A up here, right, we label the side across from it as side little a. Okay, so sine law involves the pairs, right? Sine A over A equals sine B over B equals sine C over C. Personally, when I'm using sine law, I like to write it to reflect what I'm solving for. So if I was solving for a side, right, we can just flip that over, and it would be something like A over sine A equals B over sine B. Okay. And we only ever use 2 of those at a time when we're solving. Okay. For cosine law, okay, it looks a little bit like the Pythagorean theorem. It's c squared equals a squared plus b squared minus 2ab cosine of c. Okay, again, you can rewrite that depending on what you're looking for, right? If you're looking for a, okay, then we just swap the positions. It'd be c squared, b squared minus 2cb cosine of a. Right? The key thing is that this side here and this angle have to match, and the other 2 sides slot into the other 2 positions. So cosine law is more useful when you have all 3 sides and you want an angle, right? It's an entry point for an angle, or if you know 2 sides and the angle in between them, which means you can't use sine law. Okay, and we're going to move on to the next thing here. Okay, one thing And I know I just taught the 3U, so I know it was in there somewhere. Okay, for what's called ambiguous case of the sine law, right? So when you're solving for an angle using the sine law, there can be multiple solutions depending what's going on. Okay, so this is a situation where you know two sides, you know an angle. So in this diagram over here, I'm saying that I knew what side B and side A were, and I'm looking, I know angle A, and I'm looking for angle B. Okay, there's actually two possible positions that A could sit in depending on what the length is. Okay, so here's how you check. So first condition is that the angle A, the one you know, has to be less than 90 degrees. Okay, if A is longer than B is, there's only one possible solution. Okay, so if B is the shorter side and A is the longer side, there's only one triangle you can get there. Okay, if the height of the triangle is shorter than A and A is shorter than B, then there's two possible triangles. Okay, and when you solve for angle B, then 180 minus B is also a possible solution to that angle. So I'm just going to scroll up for a second. That's the situation I've drawn here. Okay, the height, right? If A is a little longer than the height, but it's shorter than side B, well, you can have an acute angle here, or you could have 180 minus that angle, the obtuse angle, and they're both valid answers for that problem. Okay, a quick check to see if that's the case. That's this right here. Okay, right? The height of the triangle is equal to B sine A. Okay, so you can figure out the height and then compare it to A, and you'll know if you're in that situation or not. Okay, finally, okay, if A is equal to H, so I guess not finally here, if A happens to be equal to the height, okay, you find out what the height is, and it's the same as A. There's only one solution because it is the height, and so the angle is 90 degrees. Okay, if it turns out that A is less than the height, then you can't make a triangle, and there is no solution there. Okay, so once again, pause if needed to make sure people get stuff down, and then I'm going to move on to the next thing. But I would like you to do, actually, and I don't have the cards, obviously, in front of you there, but if you can get into some small groups, okay, I want you to try this problem right now. So I'm giving you some information about triangle ABC, and so I would like you to go to the whiteboards and try to solve the rest of the triangle, right? Find angle B, angle C, and side C. Okay, so I'd like you to do that for a couple minutes and then come back. Okay, so I'm going to reveal the solutions now. So hopefully we've paused the video if we're not ready to look at them. Right, but here are the two possible things you can get. Okay, right, solution one, if you go through, angle B is 59. When you first solve for it, that leads to C being 81 degrees and side C is 13.8. Okay, when you hit angle B, the other option looks like this down here. Okay, so that's doing the whole 180 minus 59 gives you 121. And then when you redo the information for C, you get angle C is 19 and C is 4.6. Okay, and there's the time here. Okay, you can do the solution with cosine law. Okay, the full solution is in the notes on the website, but I'll just quickly give you a flavor of how to do that here. The idea is that you're going to set up cosine law, but use it a little bit weird. Okay, so my target side is C, but I know angle A, so I have to use the version with angle A. So if you fill in the other information, you end up getting something that is quadratic in C. Okay, and then we can use quadratic formula to solve that. Okay, and you get the two options we got for side C going through the other way with sine law. So it works in both ways. Okay, again, I'll invite whoever's running the video to pause it I'm going to give a couple different spots there if people want to copy this down. But if you don't like ambiguous case, the sign law, this is an alternate way you can deal with that. Okay. All right. So that's it. That was a very express introduction, okay, to this. Here's practice questions I would like you to look at from the textbook. Okay, I know you don't have the textbook, so I left instructions with the covering teacher. So either you're going to get a handout or my textbook is on the desk. People can come up and maybe snap a picture of that with their phone. Okay, and that's what I'd like you to work on for the rest of class. Okay, thank you for watching, and I will see you tomorrow.